All right, so last section for chapter 3, measures of position. So we discussed 3.1 measures of center, 3.2 measures of variability. Next is measures of position. So we have all these objectives. You will learn how to compute and interpret z-scores. Next, compute for the quartiles and percentiles. Then a 5-number summary for a data set, and the effects of outliers, and how do we construct box plots using the 5-number summary. So compute and interpret the z-scores. So take a look at this. Who is taller, a man 73 inches tall or a woman 68 inches tall? So the obvious answer is that the man is taller. So however, men are taller than women on the average. How about this? Suppose the question is asked this way. So who is taller relative to their gender? A man 73 inches tall or a woman 68 inches tall? So one way to answer this type of question is we're going to use the z-score. And a z-score tells us how many standard deviations that value is from its population mean. For example, one standard deviation, remember we talked about yesterday for empirical rule, how many standard deviations away from the mean. So for example, a value 1 standard deviation above the mean has a z-score of z is equal to 1, and the other one has a z-score is equal to -2. So we're gonna use, I want you to copy the formula here. Z-score is z is equal to x minus the mean over standard deviation. So again, z is equal to x minus the mean over standard deviation. All right, so let's answer this problem here. Who wants to read this problem? Volunteer.
A National Center for Health Studies states that the mean height for adult men in the U.S. is U equals 69.4 inches, with a standard deviation of O equals 3.1 inches. The mean height for adult women is U equals 63.8 inches, with a standard deviation of O equals 2.8 inches. Who is taller relative to their gender? A man 73 inches tall or a woman 68 inches tall?
Thank you. So given men mean is 69.4 and standard deviation 3.1 inches. For women, mean is 63.8 and standard deviation is 2.8 inches. So who's taller relative to the gender? A man 73 inches tall or a woman 68 inches tall. So we're going to use the formula x minus the mean over standard deviation. So for given x, a man 73 inches tall, so that's a 73 minus the mean, 69.4 over 3.1. Use your calculator, find the answer here. And the other one, woman, z is equal to, given a woman 68 inches tall, so 68 minus 63.8 over 2.8. What is 73 minus 69.4? Then divide it by 3.1.
1.16.
1.16. And the other one?
1.5.
1.5. Thank you. So copy that if you want to. So to answer the question, who is taller relative to their gender? So that is, the woman is taller relative to the populations of women's heights, because you're comparing this 1.5 and 1.6. Okay. So remember again, yesterday we talked about the empirical rule. 68% approximately of 68% of the data will have the z-scores between -1 and +1. Then 95% between -2 and +2, and almost all, or 97.7%, from -3 to +3. Those are z-scores. And like what I said, we're gonna have a whole chapter 7, all about normal distribution, all about this bell-shaped curve. So for now, we just need to learn the z-scores 1, 2, 3, -1, -2, -3. So next, compute the quartiles of a data set. So you know now how to compute for the mean and the median. So sometimes it is useful to compute the measures of position other than the center. And first is all about the quartiles, and that divides the data set into 4 equal pieces. So again, definition: quartiles divide the data set into 4 approximately equal pieces. So you have the first quartile. We use it as Q1, meaning that is the lowest 25%. Next, Q2 is the second quartile, which is 50%. And Q3 is the third quartile. And since Q2 is 50%, so meaning this is also the same thing as your median. Because remember, the median is the middle, right? So how do we compute this? So it's the same thing like what we did for the median. Oh, do you remember how to get the median? Given set of numbers, how do we solve for the median?
If it's an odd set of numbers, it's the middle number. If it's an even set of numbers, it's the 2 middle numbers.
Yes, that's correct. But before that, what do we need to do first?
Put them in order.
Yes, so arrange them. It's gonna be that should be your first step. Arrange the data in increasing order, and then you'll be able to compute for Q1 and Q3. So actually, I don't want you to spend time using these formulas here, but we're going to use this later for percentiles. So for Q1 and median and Q3, so get your calculator again. If you already have the data for this example earlier, so try again, get answers to stat arrow to the right calc, and then 1, and calculate, and you will see, scroll down, you will see Q1, you will see median and Q3. Median, we know that is the same thing as Q2. You will see Q3, right? So what is Q1? What is your Q1?
29.
29. And what is your Q2 or your median?
30.
And your Q3 is?
32.
So you should see these numbers. Okay? Any questions to find Q1, Q2, and Q3? All right. You don't need that. Again, if you want to go back how to use a graphing calculator, all the PowerPoint presentations, you will see a slide about how to use it, just like this one. So again, enter the data into L1, press stat, and then arrow to the right to highlight calc, and then run number 1, which is one variable stats, and you will see all the answers. All right, so visualizing quartiles here. So following is a dot plot of LA rainfall data with the quartiles indicated. So the quartiles divide the data set into 4 parts with approximately 25% of the data in each into 4 parts. So you have here median, the third quartile, and the first quartile. You have also the smallest and the largest value. And we're gonna need this later, the very last objective for this section. We need all these numbers actually to construct your 5-number summary. Next, percentiles. So earlier, quartiles divide the data set into 4 parts. For percentiles, you divide this into 100. So that's why you're gonna have P1 up to P99. So for quartiles, you have Q1, Q2, Q3. For percentiles, you have P1, P2, P3 up to P99. Okay. Now, how are we going to solve these percentiles? So again, arrange the data in order. Then to locate it, use L is equal to P over 100 times N. So copy that. And take note of step number 3. If L is a whole number, then the P percentile is the average of the number in position L and the number in position L plus 1. So you have to take the average of the two numbers. So again, that is when computed L is a whole number. When it's not a whole number, then round it up. All right, an example here. All right, so what we're going to do here when arrange this, this is in order. Okay, so we want to compute for the 60th percentile. So first, solve for L is equal to, again, P over 100 times N. So your P is 60, so 60 over 100 times what is the total N here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15 times 3 is 45. So what is 60 over 100 times 45?
27.
27. And it is a whole number. So if it's a whole number, L meaning the location, so look for the 27th number among these 45 numbers. So we know that this is 15, this is 16, 17, 18, 19, 20, 21, 22, 23, 24, and 5, and 6. This is the 27th number. So, but if it's a whole number, you have to get the next one and get the average of these two. So it's 3.57 plus 3.58 divided by 2. So when you get this, the average of these two is 3.575. Okay, so that's why your P60 is 3.5. Questions? Let's try another one. So let's say I want you to try on your own. How about, let's say P, what is P? What's a good number? Let's say 33. So P33, So find L first. So that is 33 over 100 times the total N, which is 45. So 33 over 100 times 45 is
14.85.
yeah, 14.85. It's not a whole number, so you just have to round it up. So that is going to be 50. Okay, so based on the numbers here, what's the 15th number? So the first row is 1 up to 15, so the answer is 1.30. Okay. Questions? Or another one, I want you to try again. About P72. Two minutes, solve for P72. So what do we do first here again?
$72 over 100.
Yep. So L is 72 over 100 times. N is that all these numbers, that's 45. And what is the answer here?
32.4.
32.4. And then remember, you always have to round it up. So round up 32.4, that is 33. So what is the third number here?
4.64.
So first row is 15, the second row is 30, 31, 32, 33. So the answer is 4.60. Okay. Any questions?
No. Nope.
All right. Next one. All right, computing percentiles. We already have it. Okay, next one, computing percentile from a given data value. So again, always arrange the data in increasing order. And then to get the percentile, I want you to copy this formula here. That is 100 times the number of values less than X. So you have to count how many values, how many those numbers less than X, and then add 0.5 and divide it by the number of values in the data set. So again, copy the formula, 100 times number of values less than whatever the given is plus 0.5, and then all over the number of values in the data set. Okay. All right. An example here. So the following table presents the annual rainfall, so same as earlier example. 1 year, the rainfall was 1.90. So what percentile does this correspond to? So locate where 1.9 is. This is 1.9. Okay. Then to compute for the percentile, this is equal to 100 times, count the numbers below 1.9. How many numbers below 1.9?
18.
18. So 15, 16, 17, 18. Plus, always don't forget to add 0.5. Okay, and then the total n is, so n is 45. And then now compute this and round off your answer. So 100 times 18.5 over 45. What is the answer?
$41.1.
So round off the answer. So meaning you can write that P41 is equal to 1. Okay. Any questions? Okay, I want you to try this 6.61. What's the percentile of 6.61? It's gonna be 100 times. You just have to count how many numbers below 6.61.
Is it 37?
37 plus 0.5, so that is 37.5. divided by 45. And answer?
83.3.
83.3, round off. So this is gonna be P83 is equal to 6.62. Okay, any questions? No, you just have to round off your answer. So earlier you have to round up. This one you have to round off your answer. Good question. Okay. L is the location. So because you want to locate that number. All right, so next one. So we got those answers. So next one, compute a 5-number summary for a data set. And you just have to remember all these 5. When you use a graphing calculator, when you scroll down, you will see all these 5. The minimum, the first quartile, the median, the third quartile, and the maximum. Just like the data that you have when I asked you to enter those numbers earlier, try to get those numbers again. So start calc 1. When you scroll down, you will see minimum is, what is minimum?
The minimum is 0.
No, use your calculator.
Is it 24?
It's 24. Then you have Q1, 29, median 30, 32, and maximum is?
38.
So when you again try to do this stat, and then calc, and then 1, calculate, and you will see, scroll down, you will see these answers. Okay. We don't need to do that for this. I don't want you to enter all these 45 numbers. All right, so that's how you get the 5-number summary. So next, understand the effects of outliers. Copy this definition of an outlier. It's a value that is considerably larger or smaller than most of the values in a data set. So some outliers result, you just have to copy the first sentence. So some outliers result from errors, for example, a misplaced decimal point. So it will change. It will definitely affect your answers. So make sure to enter the correct numbers when you solve all this. All right, so the temperature here given is measured for 8 consecutive days during the summer. So the readings in Fahrenheit are 81.2, 85.6, 89.3, 91, 82.2, 84.45, 79.5, and 87.8, which is an outlier here.
8.45.
Definitely is an 8.45, and definitely it is an error, right? Because there's no 8.45 during the summer. Next, interquartile range, IQR. Copy this formula. It's just the difference between the upper and the lower quartiles. Q3 minus Q1. And we need that to get the outliers. So IQR method for detecting outliers. So find the first quartile, then the third quartile. You know how to do this now, right? And then all you have to do is just find the difference between the two. That is your IQR. And then copy these two formulas here. So the lower outlier boundary is Q1 minus 1.5 times the IQR. And then the upper outlier boundary is Q3 plus 1.5 times the IQR. So an example here. So the following table presents the number of students absent in the middle school in northwestern Montana for each school day in January. So identify any outliers here. All right, so let's practice this. So I want you to enter these numbers. How do we enter the numbers again? That's 1. Since you already have, you can erase the numbers, or if you already have numbers here, you can just enter it into L2. So try that. So enter these numbers into L2, the second column, 65 up to 51. 65. Okay, so next to get the answers, start But this time, don't forget to change the list. The list, since you entered these numbers into L2, so this should be L2. How do you enter L2? So that is press second. So second to enter L2. And then calculate. And we need your Q1 and Q3.
Q1 is 45 and Q3 is 59. I think.
Thank you. It'll just erase. All right, so Q1 is 45. Very good. So now you'll be able to answer, get your IQR. That is Q3 minus Q1. 59 minus 45. So IQR is 14. Yes. Then to get the boundaries, lower outlier boundary, and the formula is Q1, which is 45, minus 1.5 times the IQR, to 14. Upper is Q3, which is 59, plus 1.5 times 14. What are the answers here?
$24 and $80.
Thank you. So, meaning out of these numbers you're given, anything below 24 and above 80, those are outliers. Do we have outliers here? Do you have numbers below 24 and above 80?
No.
No?
100.
100, yeah. So we actually have one outlier, which is this. Okay. Any questions? So again, that's how you get the outlier. So first solve for, get the Q1 and Q3, solve for IQR, and then you use the formula so that you know the boundaries below the number and above the number. Questions? Questions?
No.
Thank you. All right, and the last part of this section is constructing box plots. And all you have to do is use the 5-number summary. So copy the definition. It's a graph that presents a 5-number summary along with some additional information about a data set. And this is an example of a box plot. So this one is the minimum. So remember the 5-number summary: minimum, Q1, the median, and the maximum. But if you have an outlier, these are outliers here. This is gonna be the upper boundary. That's why I showed you how to compute the lower outlier boundary and the upper. So we're using the same example here. So when you use, again, StatCalc, let's get a 5-number summary. You already have this answers here. So 5. So what is the minimum?
41.
So you have minimum is 41, Q1 is 5, median is 51, Q3 is 59, and maximum is 100. Okay, then how do we create a box plot for this? So we know that earlier we have an outlier. We solved that an outlier is 100, right? So here, since minimum is 41, so let's say this is 41. Let's say this is 45, and this is 51. Doesn't look good. Let's say this is 41. Let's say this is 45. This is 51. Let's say this is 59. So this is your minimum, Q1, median, and Q3. And since we have an outlier of 100, so what was our computed upper boundary? What was the computed upper boundary earlier? 80. So that's gonna be 80 here. And you have an outlier here, which is 100. So this is an example of a box plot. Any questions?
No.
So if you don't have an outlier, so this is going to be something like this. So whatever 5-number summary you have, this is going to be minimum, and this is going to be the maximum. And then Q1, median, and Q3. Okay, so this is a box plot without an outlier. This one, since this example has an outlier 100, so this is going to be the last number here is the upper boundary, and you have a dot here for an outlier.
I do have a question actually. I think it's in the next, if you click, or I think they use their max instead of 80 was 77, because that's the highest value under 80. Is that true?
Yeah, that's correct. Thank you. Yeah, I thought there's an 80 here. So yeah, so based on the numbers here, since your upper boundary is 80 and we don't have 80 here, next below 80 is 77. So that should be, this should be 77. Thank you. Any questions? Questions? No? All right.
No.
So that's it for chapter 3. So your test is up to the box plot. So there is one problem about this, so make sure that you know how to construct a box plot.